Uh, you're gonna have to let him in the door. I don't, it's slow today. I sent out a message. I was waiting, and nobody got on.
Zoom wasn't working for me today for whatever reason.
You
Not
mean
sure why.
your earlier class?
No, when I was trying to join this one, like it had the loading, but it didn't.
Yeah, that's exactly what I was. It's got some kind of a problem right now. So apparently there's social media threads of students complaining about online classes or complimenting some people that do, I guess, they do online learning constantly. And the big thing I want to say about this, when I had to teach a course with one student who was distant, they had a camera, a high resolution camera in Ramsey, and I could do my lecture on the board, and it was crystal clear what I was doing. So I could literally do the lecture on the board in front of the class. And then the person, it was a distance, they could see everything positive. I mean, it was just like an in-class lecture to them about, and they could even, if they wanted to, question it. But what I think a lot of people are experiencing is their instructors have never done this, and some of them don't even know document cameras like mine are available. So they're forced to use tablets if they have them or whatever is available to them, and they're kind of, I guess, for some of the instructors that are technically challenged, they're having a tough time of it. You all heard about these threads that are out there on Reddit, and I don't know where the other ones are, but they're more or less letting loose with their feelings. And I'm still waiting for some more people. We got 16. We usually we get about 24, 25. Anybody else got any comments about what's going on these days or how your courses are going or anything? You can unmute. You might as well have a conversation. Nobody?
My birthday was Monday.
Happy birthday, Ruth.
Thanks.
So how old are you?
21.
It's a bad time to turn 21, isn't it?
Yeah.
It only happens once, and the things you want to do, you can't.
Nope. It's right before finals week, too.
Well, I hope you had a good one anyway.
I mean, my doctor was nice.
Oh, yeah, you had a virus. You over it?
Kind of.
Kind of. I got another kid in the class that he thinks he has the COVID-19 virus. He's been self-quarantined, and he hasn't experienced terrible symptoms, but I want to tell you that only 10% of the people tested actually that do have the flu test with the COVID-19. So if you have the flu, don't assume it's COVID-19. All right. I think we got 17. And anybody experiencing, I know somebody lost a fence in Montgomery from that storm, the storms that came through. Anybody else experiencing damage? Nothing. I'm glad. I had a lot of flooding. I mean, a lot of flooding. Pine straw gets washed away that you put down. And in general, everything looks like it was in a swamp for a couple of days. Okay, admit.
Yeah, I had a friend had a tree go down in his driveway, but in Montgomery. But
okay, I think we got a critical mass here. Just keep on looking if you need to admit people, because I won't be seeing what you're seeing if I share my screen. It's a little different. And if somebody wants to share a screen and ask a question, please just let me know. And as always, it helps if I can see your faces, even though some of you don't want to be seen because you're probably looking like you just got out of bed, because you probably did. Or you're in bed, or you're eating breakfast, or whatever reason. But it helps me if I can see people and at least try to get a read on the class. I'm going to ask about the homework, but I'm going to go ahead and cast a screen. Let me go ahead and first get this document camera going. Oops. We had a meeting this morning, a Zoom meeting with the President's Council, and they're discussing all the planning to do this fall. And from what I can tell, it's the planning for a worst case scenario is everybody's off campus. And more or less, whatever you need for your to have a remote delivery, like document cameras or larger tablets or whatever, just get them now. Assume worst case. That way, even if you don't have to do that, you can still use these teaching tools. I'm planning to do every single lecture that I have, if I'm allowed to, with somebody with a Zoom camera doing it. So it can just be, loaded up to YouTube. That way, even if there's somebody remote that can't get to class or doesn't want to come, they can view it live and ask questions live. I don't know. Do you have any other comments about this? Because we're being asked, like, what do students think about remote learning, and the students have any feedback or ways to improve it? I'm doing this because I'm told to do that, and you're supposed to fill out these student evaluations of teaching. So please do that too, if you haven't. And don't worry, I don't know who says what, and it's not going to affect you because I never see them until after you guys are. I'm done. I basically don't see them until after I'm done grading.
Yeah, I know they sent out a long survey, like a 30-minute survey about like study habits and access to materials and all sorts of stuff.
Anytime you ask more than about 5 minutes worth of stuff from a kid, you're going to get a response rate that's less than 20% usually, unless it benefits them directly that they know they're going to get something for.
Has there been any talk from the university about fall semester? I know
Yeah.
I've heard some colleges are debating not coming back until spring.
Well, I'll tell you what they're doing right now. They don't make that real call. The governor does of the state. And really, it's the CDC in Washington ultimately are going to make that call, whether you can or can't, because this is a state-funded university and we get federal funds. And if we're ever going to endanger students, we're liable. So remember, there's a lot of legal issues, and there's also governing issues that are far beyond what the Board of Trustees can do. They have limits. And however, that said, all these models are predicting a second wave in September. Just got out of a meeting, they were talking about this, where it would be concurrent with the regular flu season. Now, those two combined, the synergetic effect could really put pressure on the hospitals for the number of ventilators. And that could possibly mean that they will go to I'd say a nationwide, I want to use the word quarantine, not curfew. In other words, you're going to be subject to stay in your house or just outdoors, and all stores and everything would only have curbside services with people in full battle gear, with masks, gloves, the whole 9 yards. Because the problem is, this will come due next year, you'll hear about it. There's areas where they didn't have enough ventilators, so people literally died because they didn't have hospital equipment available. And there's a whole lot of that happens when you get a massive surge of this virus in an area. I mean, and the thing is, it's transferred by just walking by somebody and breathing around them for a while. You don't have to touch them. And that's the problem with this thing. In restaurants, there was one thing in Wuhan. They looked at workers in a restaurant, and they had a whole bunch of people that were in the restaurant. I met him, that didn't catch it, that were working in the kitchen, that were working and cooking and preparing food, as well as the deliverers of the food. But the people that got it were actually the ones that came down and sat down at a table, and they were close to somebody else. The tables, I guess, are spaced 6 feet or 10 feet away, and it was just from breathing the air. So that's why subways, unless you're protected, subways, buses, anything like mass transportation, those are like the perfect place for this thing to spread like wildfire. I don't recommend you take mass transit unless you absolutely have. And if you do, you wear protective gear. I want to say this about fall. I'm supposed to get feedback from the students about how you could how I or anybody else could make the course better in a delivery system. I've already got some ideas. One is this document camera is going to take a special place, and I'll be probably improving the way I deliver with this. And the second thing is also having slides I can easily go ahead and access and point to. Now let me get this shared screen. If anybody else has a comment, go ahead and share it. You should be seeing a screen with a bunch of icons right now. And let me see if I get, go ahead, I'm sorry.
Oh, one thing the one of my professors does is that he has slides with like notes on the side. And so he prints out the slides with like worked examples, and then he just works through them on the side. So you have like the slide and the work
Cool.
on the same page for a DocCam.
That's a good idea. This thing, my DocCam didn't come up for some reason.
I know something else that's helpful to me is, when you're working with the DocCam, is then putting the notes up just to be accessible, without the video later.
Okay, without the video, just like take snapshots of everything.
A lot of times it's enough to jog my memory if I just see it again.
Not a bad idea.
One of my professors does that as well. Like he uses everything with the DocCam, and then he posts the notes onto Canvas afterwards as well of everything.
Yeah, I'd agree with that. Like, if you could take pictures of your each page of notes that you take throughout the class, and then just upload those to Canvas. So you have the option of just reviewing the notes, or
Hey,
video where you explain it and how
That's a
you
good-
worked it.
that's a good idea. I'm going to do that. By the way, does anybody have any problems with the videos? I mean, they're available, and I think some of them even have a transcript, right? Or not?
A few of them, they're pretty early though.
If you want a transcript, I can probably have one. I'm not sure that's really helpful though, because they don't capture it.
Transcripts are pretty bad.
Yeah.
They're not accurate, but
You'd have to have someone to go in and like watch the whole video and type it out, type the thing out if you want like accurate captions.
Whenever they do this in our Senate meetings, I mean, they try to have the speech to text, but it renders stuff terribly. A lot of things. So you have to go through it. Somebody has to correct all the words that were inaccurately translated. Now I wanted to get back to the questions about the homework. Does anybody have any questions about homework? This is the deconvolution section.
I was lost on all of it. I could not figure it out. So
Okay, well,
yeah.
the solutions I believe were there, right?
Oh yeah, way down at the bottom. They are.
They should be.
Big, though.
Well, no, they're not. Just wait a second. If you really didn't put your heart into it, you probably didn't get much out of it. Deconvolution is pretty straightforward. And this is if you want to find x of n, but you have y of n, and you also have this, which is what? The h of n, correct? Do you all agree with that?
Right. Mm-hmm.
All right, well, what does this really mean? Here, if just follow me on this, that's what I'm talking about right there. Let me see if I can actually, I'm going to do a snippet. No, I'm not going to do a snippet. You have your books. Let's use that approach, correct, class? And if you have your books, then you can see that that's 15, is it? I think, right? Yeah, it is.
Mm-hmm.
They give this for 815, sorry. This is 815. And they simply say that I have x of n, and it's convolved with, and this is going to be the h of n for 0.0, 1, and 2. So it has 1, it'll have an underscore. Then it'll have 1.
What page is this on?
It's on
Well,
470.
Page 470, yeah, thank you. And remind me to take a picture of this, somebody, but it's literally the solution. It's in the solution there. So, and then 1/2, I think, right?
Yes.
Okay. And that's equal to, and this is the y here. Then they have 4, it's actually a curly bracket, and there's an underscore there. So that means y of 0, that's n equals 0. Then they have 6, 12, 15, 10, and 3, correct? All right, now, if you look at this right here, that's saying this is really x of n times convolved with h of n, right?
Mhm.
All right, so that means h of n is equal to 1 underscore 1 comma 1/2, right?
Mm-hmm.
Now, if you wanted to turn this into a difference equation, y'all remember that if what this is really saying is, in terms of delta functions, this is delta of n plus delta of n minus 1 plus 1/2 delta of n minus 2. Do y'all agree with that?
Mm-hmm.
Right, I mean, I'm just putting it down in terms of delta function. Well, it's operating on this x of n for convolution. So if they're convolved, what happens? Then if I look at this in terms of x and y, I have x of n, right? Plus x of n minus 1. I think this is the way he does this, but I'm not sure. Plus 1/2 x of n minus 2 equal to, and then the first one there with the underscore is, that's y of n equals 0. So it's going to be, if you think in terms of just n, that would be y of n plus 12 y of n minus 1 plus 15 y of n minus 2 plus 10 times y of n minus
Dr. Baginski, quick question.
once.
Where did the
Go.
4 and the 6 go with the
Yeah,
y of n?
Hold on with this. Stop.
Okay.
Let me stop right there. I'm getting way ahead of myself for this. When you have this, the 4 is at n equals 0. The 6 is at, n equals 0. The 6 is at n equal 1. So that's y of 1. This is y of 2, y of 3, y of 4, y of 5. You follow me?
Mm-hmm.
As a matter of fact, there's a page in the book. I thought I did this for you, but I might be wrong. This is on page 440, the minimum phase system. And actually 441, example 8.7 shows this. And I should put it this way. Do this again. Here, let me back up a second. Before, when we had x of n convolved with h of n is equal to y of n. I think everybody understands that, right? That's just standard. Let me blow this up a little. Right? Come on. All right, now in the z domain, it would be x of z equals, or x of z times h of z is equal to y of z. And if we had y and we wanted x, it would be y of z divided by h of z would be x of z, correct? Now, if we think about this in terms of, well, no matter how we do it, if we think of the difference equations that go with this, let me just do it this way. Put it back this way. I know that when I have h of z, let me do it this way. If I have h of n is equal to 1 comma, 1, comma, 1/2. This would be for n equals 0, n equal 1, and n equal 2. Agreed?
Mhm.
All right. That means h of z for this one, h of z, if I look at this, this is really, I'll write it out this way so you can see it. This is h of n is equal to 1 delta of n plus 1 delta of n minus 1 plus 1/2 delta of n minus 2. That would be h of n. Do y'all agree with that first?
Mhm.
I mean, if this is mathematically, the way they put it is this, they use curly brackets and do it this way. But the actual math statement is this, right? It has delta of n minus, delta of n minus 1, and delta of n minus 2 weighted by a coefficient 1/2. Agreed, class? Yeah, I'm getting some head. All right, I'm trying to do this as easy as I can. So what is h of z? Well, that would be what? Delta of n goes to 1, right? Y'all with me? All right, and then it's plus what?
C to the negative 1.
Z to the minus 1, right? Plus z to the minus 2, correct? Times 1/2, right?
Mhm.
Y'all agree with that? All right, now think about this. If I have x of z times this, 1 minus z to the minus 1 plus 1/2 z to the minus 2 on that side is equal to y of z, right? Y'all agree with that? I think you're going to see it in just a second. Well, if that's the case, then what is the difference equation? Well, the difference equation would be x of n, right? And that's a plus. And that's z to the minus 1. Plus x of n minus 1, correct? Plus 1/2 x of n minus 2, right? Y'all with me on this? Remember we did this, the difference? Normally we had polynomials. We multiplied one side by the, we multiplied both sides by the denominator, and then we had a polynomial in z on times y, and we had a polynomial times x, right? Do y'all remember this? Well, this is even simpler because we have the impulse response. So this is going to be just what? Y of n, right? Are you with me? And let me just take a picture of this. I don't think the information above was of any benefit, but what I'm trying to show you, I'll try to write neater, is how you take that h of n, turn it into an h of z mathematically, then see the steps to get a difference equation where I have both x and y in terms of n, right, or n minus some. Now I'll see if I can take a picture of that. I'm just going to try this and tell me if it works. Oh, I don't want to record the whole thing. I just want a picture. There should be a way to just take a snapshot.
It may be best to try and like scan the papers after the lecture. That
Yeah,
might be the best way to do it.
just for reference, Dr. Baginski, Dr. Bashir for EMAG, he does his lecture and then writes all of his notes down during lecture and then scans them and puts them into a PDF and uploads them on Canvas after each lecture, and it's super helpful.
I can do that. I can do that. I'll just take this and I'll start numbering these pages one, and I'll try to write neater. But
If you
anyway,
have an iPhone in the Notes app, you can scan them natively, like inside the Notes app, like built into iPhones as well.
I don't have an iPhone. Well, my wife does. But there's a way, I know there's a way to take a picture of this because I've done that before. Let me see with this camera.
You could just take a picture and then just put them on Word documents and change those to PDFs too.
All right. Yeah, Let me just check one thing here. I'll figure that out later. Anyway, you're with me on this, right? Down to this point? And I'll definitely make this available, take pictures of it and put it on it, send it to everybody, okay? Y'all with me on this so far? All right, well, look at what we're gonna do. We wanna get x of n. So what we do to get that, we're gonna take y, we're gonna say x of n is equal to everything else. So we get x of n here equal to y of n, and that's going to be minus x of n minus 1 minus 1/2 x of n minus 2, right? Everybody's, it's just rearranging things. So I'm getting the current value of x at the value n. And you start with 0. And this is a thing that's just like the autoregressive moving average filter. Now we're moving in n, starting at 0, and we're getting values of x based on values of y and prior values of x. And I'm going to flip this up here, all right? And then we'll do it. So when we look at this, we have x of n. This is going to be page 2. We have x of n equal to y of n minus x of n minus 1 minus x, or minus 1/2, pardon me, x of n minus 2, correct? Now, I'm going to put this down here. The values for y, again, were 4, 6, 12, 15. Once you see 1, you figure it out for all 3. Those are the values for y, and this is 0. That's n equals 0 right there. The values for, if I take a look at this, x is equal to, for n less than, I should say, 0. It's equal to 0, right? There's no prior values. With me? Because there's no prior values of y or the h of n. It can't have values of x less than n equal 0. Correct, class? So now we get x of 0. Well, that's equal to y of 0. Y of 0 is 4, right? Minus x of n minus 1, so that's 0. Minus 1/2 x of n minus 2, that's 0. Or that's 4. That would be x of 0. Do you agree with me?
Mm-hmm.
This is just, you're just going to go through this like an autoregressive filter. Now to get x equals 1, that's equal to y of 1. Well, y of 1 is 6, isn't it, class?
Yes.
So it's 6. Then it's going to be minus x of 1 minus 1, or x of 0, which is 4. Agreed?
Mm-hmm.
I make sure everybody sees this. Can you give me thumbs if you see, guys? I know I'm not seeing any of you, or most of you, and I see the top group on my Hollywood Squares page. But anybody? There we go. Got 1, 2. All right. I just need to know somebody else out there understands. I hope you all are seeing. It's not hard at all. Now, what about these last? What about the last term? What about 1/2 x of n minus? It's 1 minus 2 is minus 1. Is there an x of minus 1 that's non-zero?
Mm-hmm.
No. You assume only the values between the ranges where there's that between 0 and whatever the last value is, or things you have to worry about. So this is going to be just what? 2, correct? What about x equals 2? Somebody work this with me. Well, I need y of 2, right? What is y of 2?
12.
Should be 12.
12.
12.
Right. And then it's going to be x of what? 1, correct? Which is
Yes.
2.
2, right? And then it's minus 1/2 x of
0, which is
which is
4.
all right. And now you guys see this. And this is,
Okay.
so this is minus 2 is minus 4. 12 minus 4 is 8, correct? Do the next one. It may get on your nerves, but it serves a purpose to walk it all the way through to the end. What do we need here? This is y of 3, which is,
Dr. Baginski, quick question. I might just be looking at the wrong thing, but 12 minus, I thought it would be 6
Oh,
instead of
It's
2.
12 minus, isn't this 2 and this 2? So 12 minus 4 is 8, isn't it?
Yes, but I was wondering where the 2 came from. Oh, it's x of 1. Okay, you already determined
Yeah,
that.
yeah,
All
yeah.
right, that
You're
makes sense.
looking at y. I did the same thing.
Okay,
Are we
that
good?
makes sense. Yeah,
Yeah.
I figured it out.
Yeah, it's using the previous values of X for the last two terms.
By the way, this is
Right.
very common in real processing. When you do fast convolution and stuff like this, you take a data record and you're going to be using those prior values to get the next future value. It's the way it's done. And this is always true for autoregressive moving average filters. They look at prior values of both X and Y to forecast future values of either. Okay. What is X of 3? It would be Y of 3. What's Y of 3?
What, 15?
All right, remember, and this is an important point. Remember, this starts at n equals 0, not n equal 1. All right. So let's go ahead. 15 minus what?
The
X,
X of 3 minus 2, which is 2, so 8.
All right. Keep going.
Minus X of 1, which is 2.
Minus 1/2.
1/2 of
X
2.
of times 2. So what's this going to be? That's 15, right? Minus 9, right?
6.
Or 6. Do you agree with me?
Mhm.
All right. So that's X of 3. What's X of 4? Well, first, what's Y of 4? 10?
10.
10.
Keep going. Minus.
Minus 6.
All right.
Which would be 6.
Keep going. Minus 1.
Minus 1/2 of X of 2, which is 8.
Mm-hmm.
And that equals what?
0.
Y'all agree with that?
0. Yeah.
0.
Yeah.
Mhm.
What is X of 5?
Start with
minus
3.
0 minus 1/2 of 3,
1/2 of, I think, 6.
which would
6, which is
be
3.
3, which would end up with 0.
Yeah.
Keep going.
That's it.
Well, what's X of 6? It's X of 5, right? I'm sorry, it's Y of 0. I mean, Y of 6, which is 0, right? They're only non-zero in the range stated, right? We have, it starts at 0, and at 0 we have 4, and then it kind of goes up and then down to 3 at X equals 6, correct? Or N equals 6, right?
So it'd be what, 0 minus
They're
0
all
minus
zeros.
1/2 of 0, right? So are
Here's
they
that.
all just zeros after that?
That's right. And you can just look at these two prior values of X and you know anything times 0 is 0. So there, if Y is 0, then this thing is 0 from here on out. Now your vector would be this. You would say the X would be equal to curly bracket. And then you would take the first value, which at 0 is 4, put an underscore, and just go down the line. 2, right, is the next. And then 8, right? And what's the next one? 6, correct? And then 0. And you don't even have to put these last values if you don't want 0, correct? And this is at n equals 0, 1, 2, 3, 4. Y'all agree?
Can you slide it up just?
Yes, thank you, thank you. Y'all agree with that? The only thing I've done is just, I've structured what I've found on up here, and I put it on a horizontal line, and I put the curly bracket around it.
Did you go over one more time how you got the X of n equation?
Okay. Now remember, what I try to do is show you on the basis of the Z transform, and do you all understand how to take a polynomial Z transform and then multiply both sides of the equation by the denominator and then take that into a difference equation? Chad, do you understand that part or not?
Yes.
If you understand this, then I'm going to take you there based on that. If this is my H of n, this is really what H of n is mathematically, isn't it? All right, now a Z transform of n, just delta n is 1, right?
Mm-hmm.
Whenever I have a delta of n minus 1, that would be just Z to the minus 1, right?
Mm-hmm.
And 1/2 z, or 1/2 delta of n minus 2 would be 1/2 z to the minus 2. Do you agree with me?
Yeah.
Now, that h of n is now turned to an h of z, right? And when I take h of z, or I take x and I take the convolution, I turn it into a z transform, I get x of z times h of z is equal to y of z, correct?
Mhm.
I want to let everybody catch up with me. If there's probably more than one person that has this same concern. Now, once we have this, and I look at this and I realize it's just a bunch of what? It's 1 over z to the nth progressively, right? When I have x of z, let me just bring a page over here, because this is just a sidebar issue. Now when I have x of z times, and I'm going to put the h of z in here, 1 plus z to the minus 1 plus 1/2 z to the minus 2 is equal to y of z. I can take this and go right to a difference equation, can't I? Well, if I go from x of z, that's an x of z times 1, it's x of z, to the difference equation is just x of n, right? This z to the minus 1 is a delay of 1. It would be plus x of n minus 1, correct?
Yeah. Okay.
And then the last part would be 1/2 x of n minus 2 is equal to y of n, right?
Okay. Mhm.
Now I want to get values of x of n, so I rearrange that and put these to the other side, subtract them, and then I can forecast the values. Now I want to tell you one other thing. What you can do is, if you want this, you could take and invert this. Let me just show you this as an option. I don't recommend you do it this way, but this is an option. Actually, it might be even easier. Do you all see that x of z, whatever it is, this, if I get a common denominator for this, then what I really have is z squared, just watch this, z squared, right? Plus z, I'm multiplying both sides by z squared. To get a common denominator, you'll see in a second, plus 1/2 divided by z squared is equal to this, right? You see what I've done? Now, I want to know what x of z is, right? Correct? I mean, that's what I want, because then I can get x of n. Now watch, I can get x of z here is equal to z squared over z squared plus c plus 1/2, right? And then what do? I take it times y of z. Well, how do I get y of z? Remember how the original equation for y, I had, what was the first one? 4 delta of n. Can you all see what I'm doing here? The original y was 4. It would be delta of n, right? Because that's what appears at 0. Correct, class?
Mm-hmm.
All right, what's next? Plus, is it 6?
Yep, a 6.
N minus 1, right? Correct?
Yes.
And plus, is it 12 or I forgot?
Yes, 12.
Times delta of n minus 2, right? Keep going.
And then 15.
Uh-oh.
Delta of n minus, what is that?
3.
3. And then 10.
Delta of n minus 4 and plus 3. Delta of n minus 5, right? There's 6 terms. It starts at 0. Well, what's the z transform of that? That would be 4, right? Plus 6 over z to the minus 1 plus 12 divided by z to the minus 2 plus 15 z to the minus 3 plus 10 z to the minus 4 plus 3 z to the minus 5, right? And you could put that right there, that y of z. Are you with me? Then you could fuss with it. You could basically go ahead and fuss with that thing and see if there was cancellation. But then you would ultimately have polynomials. You would have a polynomial on top and the bottom in terms of z, right? Y'all agree with me? Now you could go ahead and you could try to do partial fraction expansion. You could try to manipulate it so that you can go ahead and directly get the inverse. Now, the basic, you'd have to first factor this in terms of poles and stuff like that. There might be a lot of cancellation, I don't know. But this way is more arduous, generally, if you have a finite number of terms. It's much easier to do an autoregressive thing, do this thing in the end domain. Does that make sense to everybody? So remember that if I'm asking for if you have like x of n convolved with some stated h of n, 3 terms, 4 terms like that, that's the h of n, right? Equal to some y of n, and you want to get x of n. Well, the easy way to do that is get the difference equation and then just solve for x and put everything on the other side. Does this make sense to people? All right, because you can see, what is this going to be? I don't know. I mean, I can see right now I got a bunch of delta functions, so I'm going to have 4 plus 6 over z minus 1 plus 12 z minus 2. I'm going to have a whole bunch of stuff here, and I'm going to have to multiply top and bottom by z to the 5th, right? So I have z to the 5th here. I've got some z's down here, and z to the 5th here, z to the 4th, z to the 3rd. I don't know if this thing will factor into that exactly or not, but that's the type of problem you're going to get. Are you with me? You actually can get term by term though. If you just have 1 here times this, well, you can get the inverse to that, but it's a pain. Just do it with autoregression. Okay, Chad? You guys good with this? Try another one. What was the next one? Was it 16, I think, right?
Yes, it was.
Can you tell me, how many people took a shot at this stuff and did it? Just by thumbs up or thumbs down or anything?
I did.
You tried it, Jacob and Aaron? Did you guys have any questions about it? I thought it was straightforward, but
I didn't get right away that you like plugged in. I didn't see the connection between the previous one and the one you were doing now. Or like you would do one at x0 and you would need x of 0 to do x of 1. I didn't get that right away, but seeing what you did, I got it now.
And these are all minimum phase systems. And what I'm telling you is a minimum phase system is another way of saying they're continually stable for either h of z or the inverse of h of z. All poles and zeros are within z equal 1, the 1 circle, all right? That's the criteria for doing this inverse problem. If it wasn't, then you couldn't do it. Generally speaking. I mean, for a finite number of terms, you can probably get away with it, but for a non-finite set of input x's given output y's, you would probably not be able to do it. As a matter of fact, you couldn't do it. You couldn't get the inverse from y if the poles and zeros weren't inside the unit circle. And again, we are only dealing with only for positive series for n positive, 0 or greater than 0. We don't talk about the n equal minus series. That's a double-sided thing. That's a bilateral type of problem with bilateral Z transforms. We don't deal with that. Now, you may deal with it with John Hung's course in controls. I don't know. And that's really something that's touched on in the graduate material. Are you with me on this one? Everybody?
Yeah.
Just, Are you there? I'm looking at massive amounts of just blackness, and I don't know if anybody. I see Aaron and Jacob. I know you two are there. Ruth, I heard you. You may have stepped away.
Yep.
I hope does anybody have any question before I go on? It doesn't seem this difficult to me once you see it, but the first time you have to see it. One more. Now, MATLAB has scripts that'll do this directly. Deconvolution. I don't worry about the MATLAB part. You can do it and use it if you want. But for 16, how do we get this one? Suppose this was an exam question on the final. And oops, let me go here. So here, this is 816, and they have x of n convolved with 8 Am I over already? If you got to go, you can go, but I'm going to finish this thing. This is really the last thing we're talking about in class is this deconvolution. The last topic. The next class is going to be review. All right, Friday. Hey, when is our final, by the way?
Wednesday.
What time?
Wednesday at 8 a.m.
All right. Can I ask, so I don't forget, can I ask all of you to make sure everybody's awake? I'm sure you know how to contact everybody by your GroupMe stuff, don't you? Make sure everybody's up by 7:30, because I have had this happen in regular 8 o'clock finals. People sleep in and they show up at like an hour and a half late and they want mercy and stuff like this. Well, this is going to have a hard close on it. So if there's a timestamp that you're late by like an hour, it's not going to work. So please, can you guys just make sure everybody that's on that GroupMe is contacted? I think do you use your phones for GroupMe or use your computers?
Usually phones, but sometimes computer.
Well, I want to try to make sure everybody is up and running for this one. You don't have to look your best, put it to you that way, you just have to do it. And I'll send it out, by the way, via email, and you can either take pictures of it or print it out. And I'll send it out, say 6:45. We'll go over the final in a bit. But I want to finish this problem. So it's this, oops, sorry. It's this, it's x of n involved with one, these are easy ones, 1/2. And then they have all this over here, 8. They have 6, 11, 8, 5, and 2, right? And they did this. Now, I'm going to change this one a little. Everybody pay attention. I want to do this just to make sure you can see a possibility for an exam problem. Instead of putting the bar there, I'm going to put the bar here. Got me? Everybody see that?
Mhm.
Okay.
That means this is n equals 0.
Mm-hmm.
This would be n equal -1. This is -2 for n. And you got to make sure you see this. This would be 1, this would be 2, and this would be 3, correct?
Mm-hmm.
If you literally want to get and just make a, a block kind of thing where you have the values of n, the values of y, it's fine. But what's the difference equation going to be from this just looking at this? Just take one look at this. You kind of already know. I could turn this into a Z transform, right? And then I could take Z transform of this, Z transform of this, right? This Y of Z. And we can manipulate it, but based on the last one, isn't this really just going to be x of n, right? Plus 1/2 x of n minus 1 plus 1/2 x of n minus 2, correct?
Mm-hmm.
Remember, that's the h, that's a convolution, and that's just equal to y of n, right?
Mm-hmm.
Are you with me? Now remember what I did. I put the 0 over here, but the 0 here is right there. You got me?
Right.
All right. Now I'm going to have x of n equal to y of n minus 1/2 x of n minus 1 plus 1/2 x of n minus 2, correct?
Mm-hmm.
Now, where are we going to start? I'll give you a hint. -2. Follow me?
Mm-hmm.
And here's why. The value, if we start at n minus 2, all right, there is a y of -2, right?
Right.
Is there an x of -3?
No.
Is there an x of -4?
No.
Y of -2 is x of -2 is what I'm saying. Do you follow me on that?
Mhm.
Mm-hmm.
And that would be x of -2 was 8. Are you with me?
Mhm.
Mm-hmm.
Now, what is x of minus 1? You guys do this. Well, it would be y of minus 1, which is,
6.
go ahead,
So then you have your value of
minus what? 1/2
what? Minus
x of what? Of what?
one of
Minus
negative 2,
Right, right, all right,
which is a
right.
value of 8.
Well, let me, and this is also a minus
And
there
that's
too. And then it's what? Minus 1/2 x of minus 3, correct?
correct.
All right. This, let me rewrite this. This would be 6, right? Minus 1/2 of 8. You can almost see, you're looking right up here, aren't you?
Mhm.
And minus what? 0.
0.
Right. Are you with me?
Which equals 2.
And that's going to be 2. So I know x of minus 1 is 2, right?
Mm-hmm.
What is x of 0? Just go up here. Y of, I'm going to write this so you make sure you see this. This is the last time I'll do it. Y of 0 minus 1/2, right? X of minus 1, right? Minus 1/2 x of minus 2, correct?
Correct.
Put in the values. Y
So
of
you've
0,
got 11 minus 1/2 of 2
right above, right?
minus 1/2 of 8.
Y'all get, y'all see that? That's how you're going to
Yeah.
do it, because you have to move. Now, if both of these were at minus 2, you'd have to start at, you would have to start at minus 4 for that one. But the base, and here's the thing too. Once you get this, right? This is the neat thing. You can go ahead and then you can simply do fast convolution. You can take x in MATLAB if you want. Type in the values for x, type in the values for h, and do fast convolution. It's a CONV function, and you can see if this comes out, in fact, and you can prove it. Are you with me?
Mm-hmm.
MATLAB has this function available to you. I know Ruth's going to go in a second. A lot of people have to go, but see, MATLAB has something that's really nice. It does this. I think I got to log. If you don't mind, just hang on for a second. Not logged in, I know it. By the way, Octave has this too if you download the symbolic packet for Octave. Is anybody else using Octave? Anybody? You are? I used Octave just to make sure I get a feel for any differences. Instead of, I think it's, instead of phase, you use the term angle in Octave, I think. There's slight differences, but fundamentally it's just about seamless. Now that I'm there, I have to bring up MATLAB. I thought I had the window up. There it is. And when I bring up MATLAB, y'all can see it, right?
Mhm.
I'm going to work in the command window just for a second. If I look here and suppose I take a vector x equal to, make it just ones. This is a really nice command, ones, and say I want a 1 by, say, 5. So that makes this. What? Oh, sorry. It's just a 1 by 5, right? And then if I want to take, say, h is equal to 2 times 1's 1 by 4. These are two square functions. I didn't indicate we're n equals 0 yet. And then if you do a convolution of this, of x comma h, you get that. Now, you'll notice there's no value of n here. And what you have to do is, if this one starts at 0 and this one starts at -2, your starting point will be -2. if this one starts at -2 and this one starts at -2, and you can actually draw the continuous time version of this and then flip and shift, and you'll see what I'm talking about. You know that the total pulse length will be double. It'll be the sum of this one plus this one, right? Total length will double. And your starting point will be the starting point of this one plus this one. And if it's -2, it's be at minus 4, right? You can go ahead and play with that, but if the continuous time analog of that, if you think about this here, because people get fooled on this. Think about continuous time, and we had something like this. This is more for reference in the future and also for the file. If you had this in continuous time, say this is my function x of t, and I had this, right? And something like that, make this 4. And then here I have -2 and 4 again, so it's the same function. And I want to convolve these two, right? Now, what do? You flip one of them, doesn't matter which one, they're the same thing. So you end up getting a 2 here, and this -4 here, right? Now, this is really 2 plus t right there, that point, right? And this is -4 plus t. If t is 0, that's where it is, right? How far back do you have to go before this is -2?
You have to go back 4.
You're going to have to go to t -4, correct? And that's where the overlap begins. Do you see that, class? Can you all see that? Just think about that. The front of this thing, if we flip this one over, this is x of t2. This is x of -t, right? Or minus tau is what I should put. I'm sorry. Are you with me?
Mm-hmm.
Take that. The upper point right here, since it's flipped, is going to be that point plus t, right? If it was t was equal to -2, it would be right there. T equals -4 right here. And that's just where they begin to overlap. Correct, class? So the bottom line, the moral of the story is take these two values and add them together. That's where your convolution will begin to have non-zero values. Where will it stop, by the way? You can get this just by looking. If it starts at -4, do you all agree it starts at -4?
Mm-hmm.
Well, where does it stop? Well, we know that the pulse will be double the width. It will be adding the widths of both of those, right?
Mm-hmm.
So this is 6, this is 6, right? Or 12, correct? So you take this and add 12 to it, and you find it stops at 8.
Mm-hmm.
And it'll do this. That's from experience. I know what it's going to do. But if I weight that as 2, the actual height would be double that if they were both weighed by 1. You play with this. Now, that's for continuous time. For discrete time, it's the same thing. It'll do the same thing, only now you're going to have discrete values and sums, not integrals.
Dr. Baginski, quick question. For 8.16, just to be absolutely sure, so when you're writing out the values of x, when you're finished with it, the underbar, which represents 0, should be on 6, right?
You mean the actual one or the one we did?
Just the one that we did, 8.16.
Yeah, the 0 would be for, actually, you see, 0, 1, 2, we delayed by 2, so it'd be on my y of 0 is 11, right?
Yes.
All right, so that means the x is delayed by 2 as well, right?
Right, okay.
So it would start at -2, and I don't have that one in front of me, but are you with me?
Yes.
Mm-hmm.
Also, another quick question. Some people are asking in the chat, like the GroupMe, what is going to be on the test?
I'll cover that Friday, but in a nutshell, you're going to have a greater weight on the later material past the first test, Z transforms, and things like filtering, Z filters, notch filters, band pass, band stop, based on the homework in large part. But again, because it's open book, open notes, the level of difficulty is going to be just like the last test. A little harder than a closed book, closed notes final. but doable nevertheless. If you've done the homework and understand it, and been at the lectures, then you shouldn't have any problem. I mean, I think in fairness, if you look back at that test, that material was all stuff that we've covered over and over again. The complexity was at a slightly higher level, but it was nothing out of the realm of possibility that you should be able to do.
Okay.
And if you're a little unsure about stuff, that's where you kind of fall apart. You kind of really have to feel confident about all phases of this.
Also, another quick question. If you haven't written the tests yet, that's fine. But how many questions are on the exam usually?
Well, 6 problems, all with multiple parts to them. So
Okay.
I usually have between 2 and 4 questions I ask about each problem. You know, if you have a problem that involves, say, continuous time Fourier series.
Mhm.
All right, I could ask you for C0. That's the average value of the function. Then I could ask you for C of n, right? That's going to be the value for any value of n. Then I could ask you to evaluate for n equal 3, what it is. And since you got calculators, that should be a done deal. Then I could ask you to, if that was, say, x of n was given and you got these values, what would the output be from a filter that had an h of omega? I give you an h of omega. What would the filter output? Remember, you have to turn it into a cosine series, right? Sinusoid cosine. And then the output is really what? It's 2 times h of 0 plus 2 times magnitude of c of n times, it's really a summation of 2 times magnitude of cn, magnitude of h of n omega naught, right? Then it's cosine of n omega naught t plus the phase angle of x, right, at n, plus the phase angle of h at n, right? And then that would be the output. And if I ask you the magnitude of the output of the 5th harmonic, you would simply say that it's equal to 2 times magnitude of c of 2 plus magnitude of h of 2, right? Because the cosine is a magnitude of 1 maximum, right?
Yeah, I might have to re-look at that again, like do a little bit of review of that question. It's been a while.
Nick
Yeah.
and Jeff, do you remember doing that where we had the filter output is always, I mean, the output of a system is always going to be, in a cosine series, is going to be magnitude of c times 2, because it's a single-sided cosine series, times magnitude of x for the values of n. And then there's a cosine of omega, n omega naught t plus the phase angle. But I don't really care about that. I care about the magnitude of the cosine, what's weighing it.
I
Good.
kind of remember that a little bit.
Yeah, I mean, I'm in the same boat. I have to like review over the stuff, but I mean, I can remember about all of it in my head. Like I know we talked about it and whatever, but
It's just like
as far
the
as
specific,
remembering,
yeah.
the entire formula and all that stuff, I'd
Would
have to
you
look back.
remind me on Friday to cover that? Okay.
To cover a problem like that where
Yes.
we do like C0,
A
CM.
realistic question. And I also want to do a convolution, discrete time convolution problem, because we haven't really done those in a while. Well, I can revisit continuous time. I think everybody's kicking themselves if they missed that continuous time problem, because it was a pretty easy problem. As far as a DTFT, you all know that the DTFT is just a Z transform problem, right? DTFT is just making Z equal to e to the j omega. And just like what? A Fourier transform for anything that has non-zero values only for t equals 0 or greater than 0, well, the Fourier transform is just a Laplace and take S and make it j omega, right? All right, now the thing about the Fourier that's, to me, very important is you can use duality. And that's why it's so nice, right? Because you can use duality to get information about going from h of omega to h of t, or really h of capital omega to h of n, right?
Okay.
Duality is the real benefit with Fourier.
So do you think that it's going to be a 50, well, I wouldn't say like the number of questions, not the weighting of the questions, going to be a 50-50 split from test 1 to everything after test 1? Or
Topics, I'm not sure how you're gonna, I'm not sure percentage wise I can do this fair. All right, I can tell you convolution's gonna be on it.
Okay.
I can tell you that. I can tell you the Fourier transforms are on it. I can tell you that Fourier series is on it. I can tell you Laplace transforms are on it. And I can tell you ADTFT and AZ and maybe 2 Z transforms or Z transform problems will be on it. So if you think from DTFT to Z and both analysis and synthesis form. In other
And
words,
like filters and stuff, is that
Yeah.
going to be
Oh, yeah,
definitely
yeah, yeah.
okay?
That is inherent to the Z transform. It's
Okay.
just like with Laplace transforms, the
And the
properties.
deconvolution, like a problem we did today,
Absolutely,
like those
absolutely.
two.
Yeah, all the
Right.
homework is those are really reference points. Those are things that indicate the type of problems. And I think you have under 30 homeworks. You have about 28, 29 homeworks. You look back, that's where I'm getting the test from. And a lot of it, a lot of it's just simply presenting concepts with MATLAB exercises. I'm not giving you a MATLAB/Octave problem for the final.
Thank you.
I don't want to have to deal with a crisis, a bunch of people going to the mental health clinic to get some kind of antidepressants or something.
Yeah, writing MATLAB code isn't it's interesting, but it's not really that fun. Like I had to do a lot of it for one of my classes last semester that was basically like the entire class was just like writing out MATLAB code, and it
What
wasn't a
class?
good time. It was computer-aided
Design?
computer-aided engineering. It's like a 50-50 class. Like 50% is MATLAB, the other 50% is SolidWorks. So yeah.
One thing, can you guys remind me to tell everybody about the grade split? 75% of your grade comes from your class grade in this course. 25% comes from your lab grade. So what I do is get your final grade by taking a final grade out of 100% in my course, all right? Or roughly, it's going to be, some people are going to have over 100 because I scale things. But out of whatever the 100% is in my class, weighing it by 0.75 and then adding plus 0.25 your percentage grade that you get in your labs.
Also, Dr. Baginski, if there happens to be a situation like last test where a bunch of people got below the curve, will there be a curve overall for the class?
There could be.
Okay.
It'd be a curve on the final.
Okay.
There could be. And I'll just tell you one thing. If people are smart, first, they're going to get their sleep. And second, they're going to not study, just cram the night before. They're going to be studying daily. If you try just the night before, you're probably going to get hammered so hard. And I see a lot of people flunk this course. I cannot tell you how many people flunk this course. I don't have the stats, but if I saw 40% or more flunk, it would not surprise me. Sometimes I see less than 10%, and it's because they don't do what they're told. They cram and they expect to get away with it. They think I'm bluffing. Talk to your friends that have had me. There's a lot of people that go down the tubes because they don't do what they're told.
Okay.
Yeah. It's just like circuits. When you had Irwin for circuits, if you had David Irwin, all right, he can warn people all he wants, but there's people that will not do anything that he asks until it's critical. And then they come to a test and they just fall on their face. Well, it's the same way in here. If you do what you're told, you're going to be fine. If you don't, I don't know. I can tell just by the people that ask questions all the time and the emails and stuff, who's really interested, who's trying to figure out things. People that are, just radio silence, and I haven't seen or heard of them since we went to the Zoom teaching. I'm very concerned. I get very cryptic messages sometimes, and I don't know what's on GroupMe because I'm taking Bill Hardgrave's advice. I'm not going there. I'm just going to let you guys, unless something comes up and you can make me aware of it, I'll let you guys go have at it, have fun, be as honest as you can with each other and help each other. But I don't want to interfere with that kind of activity. I think it's beneficial to the students for the professor to keep his nose out of there unless he's needed. And is there anything else on there that I need to be aware of? I can't tell you the last time I've been on there.
I don't think there's anything.
Yeah, I don't believe so.
Well, let me know and try to correspond with your fellow classmates. And if you have questions, I hope you're posting and you're getting responses.
Yeah, usually when someone asks a question, someone usually responds to it.
And
Will you have additional, like office hours type stuff?
yeah, I'll probably do, no.
Like
I
if
got-
we,
I got to work around my meeting schedule, but yeah, I could do that. A Zoom type of, I mean, how about a Zoom class office hour for everybody?
right, yeah, like if it's, I don't know, like a Sunday or I don't know, Monday evening or whenever,
Yeah,
just
I'll tell you,
sometime before the final,
the
I guess.
final's Wednesday. How about maybe Monday at 5:30 or something?
I mean, whatever. I guess we could do a poll or something like that,
Yeah.
or ask again on Friday when we have class. But
See what you guys can come up with. I'm pretty flexible. I got problems with meetings. 9 o'clock to 10 in the morning's bad. I got an 8 o'clock final Monday. That'll take away the morning. I got meetings in the afternoon. I'll tell you what, let me just see what I got. Because half the time I don't know what's coming up. They just stick it in my calendar. Where's my calendar? Okay, so I got 8 a.m., 9 Zoom, 10 signals and systems and office hour. I don't see anything more there. There's nothing stuck in there, but I can almost tell you that I'm going to get a 3:30 meeting here. I know that, and then Wednesday you don't really care. I don't have any. I'm almost guaranteeing you on Tuesday I'll get a 3:30 meeting, 3:30 to 5. But I don't have a radar class on Tuesday because the final's on Monday. So let me kill that.
So Tuesday, I guess, morning to 3:30.
How about, from say, if we do Tuesday from 9:30 to 11, I can do an office hour if people are available. I know I won't.
9:30 till 11 or
Mhm.
okay.
Yeah, I mean, we till 11, but let's talk about it on Friday.
Okay.
Mhm.
And again, these problems, I didn't think were going to cause any difficulty. They were pretty. I did the difference equation bit before, and I try to make it.
yeah, I was just kind of in the same boat as I forgot who mentioned it earlier. Was it Nick? I think maybe.
Yeah.
It might
I
have
was
been me.
I was just lost. Like I didn't know where to even begin. Like I just looked at it and was just
Okay. Well, I hope we cleared it up.
dumbfounded.
Today.
But I mean, yeah, when you went over it today, like I mean, it made sense. And then I was able to do the second one.
Good.
Yeah.
Taking a look. I got. Oh my goodness. Well, I got.
But yeah, that should be fine. I guess whatever works for everybody else. Like I'm pretty much open, except for exam times, Wednesday, Thursday, Friday, in the morning. So anytime when everybody else wants it is fine with me.
Mhm.
I'm looking at all my messages that have come during this class, and I'm getting meeting.
All right. Well, I think I'm gonna head out. I'm gonna check on my daughter and make sure that she's getting ready for
Her
her
class.
stuff she's got coming today.
Hey, one last thing. Is anybody on any of the social media where there's any talk about classes and stuff?
Not
Mhm.
particularly, no.
All right,
I mean, I guess kind of. Like I've seen some posts on Reddit.
yeah, that's it. There was one on Reddit that was real negative about the Zoom classes that our provost was made aware of. But anything
Well,
else on Facebook, stuff like that?
I mean,
No.
I mean, I don't have a bunch of Facebook friends that are Auburn students, so like, I mean, I wouldn't know what people are saying there. But I know on the Auburn Reddit, a lot of people are complaining, but that's what people do on Reddit. So
They need a
Yeah.
form to complain.
Mm-hmm.
It's the same as restaurant reviews. If you go to a restaurant and have a terrible time and your food stinks, like you're gonna write something. But if you go there and have a casual dinner with your wife, like you're probably not writing a review. So they're
Yeah.
biased.
The general consensus is with the evaluation of classes, the student evaluation of teaching, that the people that will speak are those that are bothered by their grade typically. If you did a great job and people like you, they don't take the time usually to express it. Some do, and I hope you guys do it. You tell me whatever you want. I won't know who said what, but the problem is if you get 20%, 25% response rate, you're doing great. Sometimes it's like less than 5, sometimes 0%, because the only thing you really care about is your grade, and that is extra work. And the students don't see a real benefit from doing it because they don't see a return on their investment of time the way they'd like. I mean, there isn't going to be a grade change. There's nothing that's going to happen in terms, and you're not going to punish the faculty either because these are used sort of as a guide. If there's a lot of complaints, then the professor is going to be, they're going to take a more careful look at what he's doing. It'll be a monitored class. And if he's making mistakes, they'll correct it one way or the other, or they'll take him out of the class. But it isn't used as, students think it's a punishment, and maybe it could be in some departments, but generally speaking, in our department, the only thing it is a guide. How can a faculty member better his class? Do the evaluations though, and just be honest. That's the only thing that matters. It used to be we handed these things out at the last class, and one student was responsible for taking them up to the main office, and then you had nearly 100% response rate. But they don't do that.
I've seen some professors actually add like a tiny bit of the percentage of the grade to the course evaluations, like 1 or 2%, and be it. So like if you fill it out, then you get this much. So
Right.
He might get away with it, but if he gets caught doing that or she gets caught doing that, they're going to be told not to do it politely the first time. Any grade, any type of effect on your grade for activities that aren't directly related to the course, like if you wash my car, if you take the survey, if you, I don't know, attend a lecture that I'm going to have that's off campus, you can get in trouble for that. You can't motivate the students to do anything but you're supposed to base your grade totally on the material in the course and nothing other than that. They'll probably get away with it if it's 1 or 2%. Unless a student.
I know at AUM before I transferred to Auburn that they set aside a specific time. It was like the next to last class or something like that or whatever, where the professor would walk in and basically tell everybody you have 15 minutes at the beginning of class that you can fill out your evaluate, and then they'd step out of the classroom and then come back in like 15 minutes. And
good.
From what I heard, they had, positive, I guess, numbers wise for responses. A lot of people filled it out just because, you're sitting in class, you kind of pull out your phone or whatever, and you could fill it out right there in class.
I can tell you that this is an issue to some faculty in other departments because I think I think it's in the College of Liberal Arts and in Education. They weigh that in. The student evaluations of teaching are weighed in the person's raise. And that's where you get grade inflation gone wild, because if a professor knows that I can get good evaluation, and they're not stupid, by giving all A's, and what do you think happens?
Sounds like a really bad policy from Auburn's raise department, I guess.
Well, it's
the HR department or whoever it is. Like,
the people that do that are the department chairs, and department chairs like simple and easy ways to figure out what your raise should be. They're given a pot of increasing fund. This is how much more you have available from your last year. Now, how you're going to disperse that is up to you, but you have to have a plan put down in writing, and it has to, or put down, it has to be a put down in writing, and it has to go to the provost's office. And if it's not approved, you can't use it. But you can do things with student evaluations of teaching and weigh those things in some way, like a 0.1 or 0.2% of the possible raise you have is based on your student evaluations of teaching. And that's when grade inflation goes crazy. And the grades don't mean anything. I mean, there's literally courses where people get all A's. It used to be one, it was organic gardening years ago. And I mean, it was basically a joke, you know, when somebody saw organic gardening on a person's resume and they look at the grade, they don't. They just, that doesn't even count. And so that wouldn't even be used when they do the re-GPA calculations. Normally they look at the grades you get and your science courses, chemistry, physics, calculus course, I mean, math courses, then your engineering courses. This is how, it's my understanding how a lot of people evaluate prospective engineers. They look at the GPA only in the courses of matter. They don't care about history, organic gardening, physical education, things like archery don't matter. And then they weigh those and they come up with a number, and then there's a threshold. You have to be above that threshold, 3.0 or 3.5, in order to be accepted by them.
Well, I might or might not be taking Auburn Moves or whatever it's called this summer.
The courses in the summer are better. I'll tell you, I'm serious, for one reason.
I was at 6 hours. I need 8 to be full-time through the VA. So
I'll tell you though,
a 2-hour physical fitness, you know, pedometer course. Sure.
You know how they're actually tracking whether there's crowds gathering and they send the police? They're using cell phones. The actual
Interesting.
government is using cell phones when they see a cluster of people in a locale. This is what we were told at this meeting. The police are actually sent there to see what's going on. And if it's an emergency management thing, if there's a car wreck or something and you got vehicles from everywhere, that's justifiable. But if you're gathering to, you know, drink beer and listen to rock, it ain't gonna work. Then I don't think they find people, but they disperse the crowd. They had a problem.
I know the federal government was talking to like Google and Samsung and a lot of other companies that have access to GPS to get analysis data on who's social distancing and who's not.
What I didn't realize is that your phone, if you're communicating in any way, shape, or form, doesn't need to have GPS on. The towers, they can
triangulate you.
They do that, and the minute they see groups of students or groups of anybody in an area like Sanford Lawn, they had to go there and I think break up a crowd, from the way it sounded, at least once. And I have not read anything about it, but we got an update on some of that stuff. And, you know, the phones are something that a lot of people are using data about your phone's location. Like it does assume it's on. That's one thing. If it's not on, you don't have to worry. But if it's on, they're using that for all sorts of reasons. First,
and a lot of investigations, like criminal investigations.
Sure. One other thing you can find out is whether this you need your GPS on for. If your GPS is on and you want to take a look at a record of your activities and the speed you're going and stuff like this, they can do that. So if you're on a highway going 140 miles an hour with your phone, they can figure that out. I don't know if they can give a ticket based on that, but they sure can keep an eye on you. You know,
you can, with that, you can actually skew Google Maps. I'd have to find the video again, but a guy got a wagon full of phones and just left it on the side of the road, and all those phones, which are presumed to be in cars, aren't moving. And so Google Maps says, oh no, we've got a big traffic jam. Yep. And so he messed up a whole bunch of GPS routes with it.
I saw that. Yeah, I saw that as well, where he created a fake traffic jam.
Sometimes it isn't super accurate though, because like occasionally my cell service just drops, and then
Yeah.
it just sees me like jumping like 3 miles down the road, and just assumes I guess I'm going a billion miles an hour. But yeah, it's not incredibly accurate, but still it tracks it fairly well.
You know, I'm going to take pictures of this. Go ahead, keep talking.
I guess that was my big issue. I know Dr. New was talking about possibly going to HonorLock or one of these other
No.
type things, and
No.
the software they make you download onto your computer is like ultra sketchy, and it's generally Eastern countries that are doing the proctoring. And I mean, I keep stuff like my bank info and things like that are all on like my computer. There's no restrictions to access. He has all my Wi-Fi information, my IP address, everything. So
Well, you know, if you don't feel comfortable with that thing, I don't think you're
I've had
forced to use it.
a lot
The
of
good-
times it's during tax season too, when people get their tax refunds. I've had my tax refund stolen twice.
Are you serious?
Yeah, back to back years, it was stolen.
Can you send
Over
me?
$6,000.
Listen,
out of
can
my
you
account.
send me information? Send it to me via email from you and say that I'm very concerned about the use of HonorLock because it's my understanding that there are countries outside the U.S. that are involved with monitoring people, and the software downloaded could be possibly used to scavenge information about my bank statements or my IRS refund or whatever, and say it that way. And I mean, just as clearly as you can, as simply as you can. Send it to me. I'm going to forward that to the provost's office because that's what they need to know. They're worried about, if people are worried about HonorLock, they'll find a way to make it work.
It's essentially spyware. Like
It
That's
is.
exactly what it is.
It
it's
scrapes your
spyware
entire
that
network.
you're volunteering onto your
Yeah.
computer, so that I understand that that's kind of how they have to do it. If they want to make sure you're not Googling answers while you're taking the test or whatever, they have to monitor your IP address and see what is going on. But then if they have access to my IP address or my Wi-Fi, like I've got over probably 20 devices in my house that are all connected to it. There's my
Really?
phone, my daughter's phone, my wife's phone, her laptop, my daughter's school iPad. Like, I'm no computer super wizard, so I have no idea like what all I'm giving them access to. And
Yeah.
Virtually
if
everything.
and if the wrong people get the access to the right things, then it goes way downhill really quick. I got
Yeah.
lucky those couple of years. It was just probably
Hey,
7 or 8 years ago, but I got
found-
lucky. My bank reimbursed me for the fraudulent charges, but essentially they just withdraw $200 if it goes through, withdraw $400 if it goes through, withdraw $1,000 if it goes through,
Ooh.
and they kept going. I went from over like $7,000 to about $300.
Dr. Baginski, I'm going to have to log off, but
Okay.
lunch. But
Take care. I think I
Yep.
figured it out.
Yeah, I'm gonna go check and make sure my daughter's working
Yeah.
on her schoolwork like she's supposed to.
I think I got the picture thing going here. Hopefully.
Alrighty.
Thank
Yeah, I'll
you.
send you that email, I guess.
Yeah.
I guess sometime today or tomorrow, whenever I get